Great. Well, good morning, everyone. Welcome to day 2 of the CySER Summer Workshop 2024. Our first speaker today is Dr. Noel Schultz, who is deeply involved in the program herself. She's one of the, founding members, you would say, and she is our lead for industry relations. And I will let her give you the details of her background firsthand from here. So, good morning, Noel.
Good morning. Thanks, James. Everybody can hear me okay?
Yes.
Yes, awesome. All right. Well, I appreciate the opportunity to present and talk a little bit about cybersecurity and power systems. I'll share a little bit about my background. So to move forward. So a little bit about what we'll talk about today. I'm going to talk about my background so you kind of understand where I'm coming from. Talk about power systems and some of the terminology that you will hear. And then the intersection of power systems and cybersecurity, and then talk about smart distribution systems as we talk about now getting closer and closer to the homes and businesses where we have more smarts in the system means cybersecurity opportunities and challenges, and then kind of industrial controls and cybersecurity. So a little bit about myself. This is my family, my husband and our 2 sons and daughter-in-law. Our son, Tim, you'll meet in about an hour. He's going to talk about AI, cybersecurity, and you. And then our younger son, Andrew, is mechanical engineer. So our daughter-in-law is computer science, and Kirk's chemical engineering. So we're kind of geeky family. And these are my parents, electrical engineering professor, and my mom's elementary school teacher. So kind of come to engineering education from that angle. A little bit about my background. I grew up on the East Coast and grew up and got my bachelor's and master's at Virginia Tech, and then got my PhD at University of Minnesota. And I've had a chance to teach at of 6 universities across the country. So from Virginia Tech, University of North Dakota, Michigan Tech on the Upper Peninsula of Michigan, Mississippi State, Kansas State, and now Washington State. So had a chance to teach at multiple different universities over the last 30 years. So my research area is, just to know a little bit about my background, is the integration of distributed energy resources, which is what DERs, into distribution systems, including storage and electric vehicles. And that could be solar, that could be wind, that could be a battery. Those are some of what we call distributed energy resources. I also work with intelligent system applications, or AI systems and power system design, control, and operations. And then outage management and storm management as we look at using different smart meters and resilience. How do we take and figure out what's happening on the grid? And then rural electrification. Actually had a chance to electrify a village in India on a project that I recently was on, and microgrids. And then I've also worked at shipboard power systems. So I wanted to share a little bit about my latest activity. I just started last August as the inaugural director of the Institute for Northwest Energy Futures. And this is a project it's headquartered on our WSU Tri-Cities campus, but across all of WSU, that's really looking at the system approach to energy ecosystem. And as we talk about that, the cyber physical nature of the power grid is part of that. So as we talk about cybersecurity that we'll talk about, that's really part of looking at the whole system. And we'll talk more about that. But INEF is located, as I said, on the Tri-Cities campus. The state of Washington has given us $7.7 million over a biennium. We have what I like to call a recycle building here, an old building that will be new to us that we'll be moving into next month. We have some administrative support, as well as we'll have 7 new faculty positions and some staff to work. And if you want to learn a little bit more about INEF, you can go to this website, and these slides will be available afterwards. I also had a chance to work as IEEE PES. Hold on a second, got to mute my phone here. All right, so with the IEEE Power and Energy Society, and PES, you may have heard of IEEE, which has over 450,000 members worldwide. PES, the Power and Energy Society, is second to Computer Society with about 37,000 members worldwide. And over those 2 years, I got to travel to 6 continents, 240,000 air miles to really work with professionals and students across the grid or across the country world in looking at the power grid. And a couple of my initiatives, one was looking at women in power and how do we get more women in the pipeline and help with recruitment, advancement, and retention of women in the power space. But the other thing I worked on was a pipeline effort about professional development. And how do we make sure that the professional society provides opportunities for you to grow after you get your degree, when you're a professional and keeping up with different things. And then one of the big areas that we've seen really a lot of work lately is looking at the overlap between power systems and cybersecurity. We have people that understand cybersecurity, we have people that understand power systems. And what we want to do more and more is have a bridge people that understand both so they can talk to each other. And you don't have to be an expert in the other one, but at least you understand some of the terminology, challenges, and opportunities in those different spaces. So that's kind of a background. And next, what I want to do is kind of talk about a couple different topics. What is a smart grid? You know, when you hear about a smart grid, what is that? What is a microgrid? What is power system security? When we talk about security, we talk about cybersecurity, but there's also physical security related to power systems. And then we've got the resilience. And we've heard a lot about resilience over the last 5 years as we talk about different aspects of life. But I want to talk about what resilience means in a power grid, and then we'll share a little bit about what that means as we're starting to talk about cybersecurity in the grid. So what are smart grids? So as I did this slide, I was thinking probably many of you may have been born after the blackout of 2003, but I won't ask you to raise hands on who was born before after the 2003 blackout. But what happened in that case? There was a blackout in 2003 of a lot of Eastern US and Canada, as well as parts of the Midwest. 50 million people were in the dark, and $6 billion in costs, as well as some losses that were there. And out of this came a big report on what were the challenges that we had. And it took them actually, one of the biggest challenges with this report, and it's a little over 20 years ago, was figuring out what came first, because people were on different clocks, so you couldn't tell which fault came first. They had to synchronize. It took them 3 months to synchronize the clock, which is kind of a weird thing as we think about it today. But so this was kind of spurred a lot of different discussions about the grid and the future grid, or how do we make the current grid smart and work from there. So what were the changes that happened in the early 2000s or across the 2000s that happened? And you know, this is really, if you look at actually all 4 of these, they have continued over the last 20 years to make advances. So one was computational capabilities and speeds. You know, one of the things we had when you took the whole grid and you tried to model it and then run a simulation, it could take hours to run simulations. But as we got more and more memory, as speeds as increased in speeds on how we could do computational activities, we now could do a lot more. We could do a lot of what ifs because we had that advances. Advances in monitoring and sensors. And basically, we have now a lot of new sensors. So we had more data than we ever had on the power system. So we could kind of have a health of the power system by all these different sensors. We could also, something that comes up later, we could kind of predict values that don't make sense. That could be someone actually intruding into your measurements and things like that. Power electronics are important. Power electronics basically are a fast operating switch that enables you to make changes in the grid. And it also enables you, as you look at solar and wind, or particularly solar and batteries, those are at DC power. So we have to convert those from a DC constant power to AC 60 hertz power. And then alternative energy, we saw a lot more things that happened related to that. And then the blackout of 2023 brought a lot of those to our attention. So as we look at these are a lot of cybersecurity implications. because we start to talk about all these kind of things as computational models, monitoring and sensors, where we have the sensors are communicating or connected to some kind of network, and then the power electronics. Now we're also seeing in the past, and we'll talk about the generation used to be far away. Now it's in your backyard. So there are chances that people could come in and malicious folks could look at how to use some of the solar and wind that's local to possibly be a challenge in moving forward. So after the 2003 blackout, there was a big, like Congress does all the time, there's a big activity like this. They came through and did this huge report. And that is really where you see smart grid used for the first time in a lot of the different aspects of the power grid. And, you know, we didn't have a dumb grid before. It's really should be a smarter grid, but it's just a term that was used. And in this report, it talked a lot about what smart grid was, the modernization, and some of the different aspects. And then you see down here, this last one, the security attributes, private wire loss, you know, some of the different things that we'll talk a little bit about, interoperability framework that come from some of the computer science computational activities that we had. One of the big things that came out of that report talked about the increased use of digital information and controls technology to improve reliability, security, and efficiency of the power grid. So there are 10 different ones here. We could talk about all of those, but this really comes down to why cybersecurity in the power system have become so much more important. And you can see right down here, the second one is optimization, including full cybersecurity. And so, but that's really the digital information now. Before, we didn't have as much information on the grid, so we didn't have as much computational power necessarily out on the grid. So now we have that. So there's a chance for people to connect to those different sensors, to change values so that things happen that we don't want to happen, like a generator ramps up or a generator disconnects, and some of those different activities. So a lot of this goes back to 2007, is really started to hear a lot more about cybersecurity at that point. So what is the increased information on the grid that we have here? And one of the things that in the past, right, you had the physical power system, you had solar cells, you had, you can see those green boxes around your house, you've got the power lines. That was a physical system. And what's happened now is we've now taken that physical system, we put a lot of different sensors all across here. We can see a meter here. We can see electric vehicles there. We can see different information about the grid. We take that and we communicate it to some kind of software that then runs it into a bunch of these different systems. And this is kind of alphabet soup here. But SCADA is supervisory control and data acquisition. And this is a long-term power grid data that's every 4 seconds information was provided. This is distribution management, geographical information system, customer information system. So these are all different systems that comes in here, and you actually do operations on this. You control the grid by this information. So as this information, you want it to be accurate, that's going to be really important in moving forward related to your running your power grid. And if that information somehow isn't accurate or is changed or even not available because of communications, then that can change how you're operating the grid. So something that came out, the North American Electric Reliability Corporation, or NERC, came out with these cybersecurity standards. And one of the challenges was utilities really, if you think of utilities, there are a lot of mechanical engineers, electrical engineers involved in these electric utilities. There wasn't as much the computer science was behind the scenes. And now we see that that's increased now that we've got all these devices out there that are now connected to networks. They can be local networks, they can be wide area networks, they can be through communications, wireless, and other ways. And so what happened is NERC had to come up with some rules on cybersecurity. And obviously, we've seen a lot of this around different utilities across, whether it's natural gas and other particular areas where people had to have rules to understand what were their cybersecurity requirements. And this was kind of a different area for a lot of power utilities, because most of their computer science people in IT were worried about enterprise systems such as Word or Microsoft products. You know, they were worried about customer information systems, not the operational side, not looking at as industrial control, as we'll talk about later. And so these are some of the rules, and I tried to put links in here if you're interested in learning more about. You can see there's a physical security, electronic security, personnel, basically reporting. You know, if there's a breach, what is the reporting of that, and so on. And this continues to evolve over time. So when we talk about increased data, and this is from 2017, if I pulled one from more recently, it kind of evolves, but that data isn't always ready up front because some of it's protected. But you can see in 2011, those blue dots are something called phaser measurement units. And then you can see just 6 years later in 2017, the data explosion of all the information, and these red links show where the data is actually sent to basically a local coordinator that pulls, our aggregator that pulls all that data and is able to look at the big picture. And I should mention, you all may already know this, but the US power grid is actually in 3 different grids. We have the Eastern Interconnect, which you see in yellow here. We have the Western Interconnect that we're part of in Washington. And then we have Texas. Texas does everything on its own. So each of these is synchronized by itself as its own grid. But you can see lots and lots of data, and you got to think about electric utility, all the different parts of a utility. There's a huge amount of data. And as we talk about data analytics and some of the other areas are related to computer science, lots of opportunities to look at all that data. But also all that data is coming in. So there's lots of opportunities for people to possibly change the data to change your operations. Or there's also an opportunity for you to have enough data that you can identify when people are changing the data. And there's an error that's either a communications failure or someone maliciously trying to change the power grid. So now all of a sudden there's all this data available on the grid. And now we have to figure out how to take that and use it and integrate it into what we're doing. So this is kind of what's happened over the last 20 years in looking at data on the electric power grid. Now, we hear a lot about resilience. Resilience is something we heard a lot about, being resilient through the pandemic and some of that. But this is this particular slide is from looking at kind of how do you define resilience? And this can relate to a cyber attack as well, as it could be a storm coming through. And so I really like this graph because it really defines where, if you think of the system at a certain state, and resilience definition is the ability to withstand or reduce the magnitude or duration of disruptive events, to anticipate, absorb, adapt to, or rapidly recover. And so if you look at this graph here, this is kind of the state of your system on the y-axis, and the x-axis is time. And so you're just kind of going along here, doing fine at a resilient state. And then some event happens right here, and we can go, oops, you can't see my screen. Can you see the cursor?
Kind of, it's there, now we can see it, yeah. Oh.
Okay, let me get the pointer. Maybe that will help. Oh, is that better?
That's good.
Okay, so you're at this resilient state here, and then all of a sudden an event happens right here. And so you go to this degraded state. And then you're in that state for a while, and then maybe you are able to restore part of it. Not necessarily all of it, but restore part of it. And then you're at that, what I'll call that stage for a while. And then you go all the way back and you're back at your original case. And what we're trying to do, what resilience is trying to minimize this time from this event to when you get all the way back to 100%. And so those, when we talk about resilience, this is, I think, a definition. You hear a lot of resilience, but this is a definition as we talk about the power grid, is wanting to get back to where we are and understanding. And so how does this relate to cybersecurity or our general recovery? Is anticipating these outages. So one of the things that happens when there is a hurricane coming through the southeast, they do a lot of modeling and they figure out where the grid, where they think there's going to be the most damage. And then so what they will do is they will have literally hundreds of bucket trucks, of utility trucks that are outside the hurricane area, that as soon as a hurricane goes through, they come in and they help with recovery and do that. And so what they're doing in that case is they're basically getting ready for this and trying to then do this recovery. But by doing simulations, by having the trucks real close, they can restore the system very quickly. And we talk about different cases of controlling the power grid. We also have a second control. All utilities have a second control center that they use. And that would be if they somehow that's separated, if they got hacked and they couldn't control it, they could switch to a different system. Or in the case that system got destroyed for some kind of weather event or something. So then you could recover based on that other system in doing that. So let's talk about the intersection of power system and just some recent thoughts that are out there if you want to learn a little bit more about this. So a couple of years ago, the National Academy of Engineering did this report on the future of the electric power in the US. And chapter 6 of this report is creating a more secure and resilient power system. And I know this is hard for you to read right here. This is available online. If you click on this link, when you get the PowerPoint, you can go and download the whole report. But this actually talks about, and this table 2, talks about traditional approaches to grid cybersecurity and cybersecurity vulnerabilities associated with individual approaches resulting from recent and future changes to the grid. And so this, if you're really trying to understand what are some of those challenges around the grid, this is a great report. Look at chapter 6. You can read through some of this. There'll be some references. You can go through this table. It talks about the challenges, traditionally what's happened, and then how that creates vulnerability. And then what are, working on solutions related to those kind of things. And that's really, as we see, cybersecurity has become very important, is looking at how do we come up with those cybersecurity threats and challenges, and how do we come up with solutions to deal with those threats and challenges. If you look at that report, there are 5 major needs that are talking about. And as we look at these, there's a lot of cybersecurity is woven in a lot of these different parts. Understanding how the grid is evolving. New technologies, as we add things to the grid, does it make it more vulnerable? Looking at also continuing to have clean, sustainable, reliant, and resilient power. How do we make sure that it's clean? So we're trying to have low, reduce carbon in our generation, but we also need to make sure we have enough electrons to meet all the needs that we have, whether it's electric vehicles or other different things that we have. And so you can see here the improved cybersecurity capabilities and information sharing. One of the challenges we have is we want to share that information, but when we share that information, we also open it up to being hacked or someone changing the information or using that in a way that we don't want them to use that. So there's a lot going on related to a lot of talk about cybersecurity. And, obviously that's why both this program as well as WSU and other schools are increasing their efforts in the cybersecurity realm. So I want to talk a little bit about smart distribution systems and how this relates to cybersecurity challenges or opportunities. So if you talk about the traditional power grid, what used to happen is we used to have basically generation. We would have a large power plant far away. We would then have transmission, long lines that would come from that power plant into our city, and then it would distribute it. And when we got to the distribution system, when we got to the substation to your house, that power was one way. It was all one-way streets. So the flow, there wasn't much control. There was just flow going from the substation to your house. And there was very little information on the distribution system. And one of the things is it was always connected, and we'll talk about microgrids here in a second. But as we talk about the next generation distribution system, now it's distributed. You can have solar on your house. You can have solar on your you can have solar on building rooftops. You could have other generation types, and that power then can come into the grid locally. And so now you have the chance that the power can go forward and backwards. The one-way street now can have 2 lanes of traffic, which changes how you control it. If you can think about cars, right? If you have a one-way traffic, you only have lights or stop signs one way. But if you now make that a 2-way street, you're going to have all that 2 ways. But there are a lot of things that are cost and interconnection to the grid. We'll talk about cybersecurity, workforce, data analytics. A lot of these aspects come because now we have a lot more information of advanced metering on that distribution system. Down to your house, we have meters, smart meters on your house that can tell power that you're using and working with that. So when you talk about the power grid, it's the ultimate 24/7 balancing act, right? If you talk about manufacturing, right, when you're manufacturing something, you manufacture it. But in the power grid, we're manufacturing electrons and they're being used, and it's a constant operating the system. You've got generation, you've got your loads, and then any losses on the system, and you've got to balance this 24/7. And so when we talk about that, this is what we call an industrial control system. And that industrial control system means that we are balancing, we're telling generation when to ramp up or ramp down. In some cases, we can tell loads when to ramp up and ramp down, where we have we're working with them to reduce their loads, or maybe they have solar and they reduce their loads and some of that. So this is all an industrial control system, and that's kind of a more recent area of cybersecurity versus Word or Outlook and some of the other IT type enterprises, is looking at these control systems where you can actually go in and you can ramp up a generator to help make it break, or you can open a switch that disconnects a load to that, or takes the lights out for people. And these are some of the things that have happened in Ukraine, is where the power grid has actually been influenced by cybersecurity attacks on the control system and working on the control system. So when we start to talk about distribution systems, we're moving into a new era where in the past, the grid was always connected. That was the goal, was always to be connected. And as I mentioned, now we have, in the old days, this distribution system would only have the green line, but now we can have power going back and forth because maybe I have storage, I have batteries, I have solar, I have wind in my distribution system. I can put that back to the grid. But now we can actually look at microgrids, that we can have microgrids that can separate and operate themselves by themselves. But the challenge is that balancing is much more precarious when you're a smaller system. When you're a large system, you have scale, where if you have a huge pond and you throw a rock in, that ripple is really small across the pond. But if you have a puddle and you throw a rock in, that is much more, any perturbation or any change is going to cause much bigger differences. So we have this case now where these microgrids can operate while connected, and in some cases they can operate on their own. And in the case of the microgrid that I worked with in India, the grid actually was totally on its own. They used solar and biomass using manure and agricultural waste to try to create power, to create a biogas that they then used to provide power when it wasn't sunny. So now this is a different control scheme, and there's a lot more controls in there and cybersecurity challenges that can be there. So when we talk about a microgrid, and this is a DOE definition is what a microgrid is. So a microgrid could be that you have your house and you have a backup generator. If any of you had a backup generator in your house, theoretically you can be a microgrid where you just run that backup generator. And then industry customers can also, if we talk about data centers, they always have backup power. So if the grid goes out, they can still keep power there. You can also have where we call part of a feeder, where like in this case, there's generation and it supplies multiple. So this could be a microgrid. And then we can have where basically a partial part of it is a microgrid. And then you can have the whole substation could be separated and do that. And that all becomes a single controllable entity that you have to work together on that. So it's something to think about is as that happens in that control, the grid it's more precarious. You're going to have to find a way to control that, and people can make a small difference in this can cause a blackout and cause there not to be power. So with that in mind, as we talk about this now, if we really look at the past on the grid, we basically had the power system, as I said, the electromechanical power system, the physical power system. We had some controls that were part, and then we've had more computational resources now, because as we have more and more sensors, what we're able to do is take the data from those sensors and do computations that then move into the controls where we tell the generation to ramp up or ramp down, or we tell switches to open or close, or we can have other ways that we change the grid. But as we look at now in the present, what we're seeing is those are all converging, and really cybersecurity is at the middle of this. Is now you've got the controls, the computational resources, and the power system. And because the power system is a critical infrastructure, obviously, having reliable power is important. That cybersecurity is really a big area where, as you understand the power system, and then you can understand how someone could come in and be mischievous and open something or change something, and then to some point get very sophisticated to create a sensor value that's an error. And then that could cause something to happen, or obviously in the communications to work with some of that. So there, that's what we really have seen. And then what we're also seeing lately is we're actually seeing the evolution now where artificial intelligence, as we talk about this, and Tim's going to talk about this in the next talk about artificial intelligence and cybersecurity. But now we're really seeing that related to controls, related to power systems and computational methods is how do we take these machine learning, all this data, because the power grid has all this data, it gives us an opportunity to do some checks and balances on our different controls and make sure they're working the way we want them to work. And so now with AI, we have an opportunity in that area, in all of these areas, to look at how do we use artificial intelligence techniques to help us identify bad data. How do we use it to look at trends and data and be able to help us predict when there's going to be, like I said, there are a lot of simulations that are done ahead of a hurricane. So how can we do more and more of those simulations so we have a better feel for what's going to happen when that storm comes through, and then we can be better ready to react and get the lights back on related to that. So what are we talking about with cyber? So basically industrial control systems is what we're talking about now. I mean, it's the grid. but that's basically what it is, it's an industrial control system. And as we talk about cybersecurity, you now have, you can see here, you now have your car that's going to be connected in here, and there's a network that's going to be in there. And so how does that data used, and how could that be information that's on a car actually come up into a system and create issues? And the data analytics, we've talked about that, and that's really, really an important part of so much data that we have. There's opportunity to use different analyses to identify cybersecurity threats, as well as to find the data. Here, it's a little hard to see, but these are some windmills. If you've ever been on 195 between Spokane and Pullman, there's wind turbines. These are some solar cells in Spokane, where we have that. These are all, these are local. These are local. This battery can be local. So now there are ways that, and there are computers that are running all this. So there are ways that people can come in and use cybersecurity to threaten the grid related to that. Some of the terms, data analytics, we talk about utilities. We talk about prosumers now, where they're a producer and they're a consumer. So a lot of talk right now about data centers being able to be used where they take power, but they can also, their backup power can possibly go back to the grid in times where they need that. We mentioned all the new sensors that are out there and what's happening. Independent power producers, or IPPs, where basically if you live in a neighborhood, someone could be an aggregator and take all your EVs, and they could try to sell the power from those EVs to help the grid. And so an aggregator kind of pulls together multiple different groups to try to figure out be a source. But all of those things are no longer controlled by the utility. We've got the utility, which is the wires, and quite often the generation. But then you've got all these different groups that are now connected to the grid that can create opportunities for cyber threats, opportunities for people to get into the data. So how do we work through to make sure we understand what those threats are, and how do we help move that forward? So with that, this is a book 2 years ago, Tim and I gave a talk here for the CySER, and he mentioned this book, and this is a really great book to differentiate, talk about the Stuxnet, but it really helps show the difference between somebody that's trying to hack into Word or Office or Outlook versus looking at an industrial control system. And so I encourage you for your summer reading to maybe think about reading this if you haven't. It's a great book to kind of just helps you get the perspective of how the cybersecurity is figuring out how they figured out this particular cybersecurity threat was very different than a lot of previous cybersecurity threats. So it really had to change the mindset. And as we look at industrial controls and that mindset, it's important that we that you kind of realize the differences that you might see in that area. So here's my email, and then next up is going to be Tim Schultz will be at 10 o'clock, so I can open it up for questions.
Yeah, go ahead and stand up.
Hi, Noel, can you hear me?
Yes, I can.
Hi, can you go back to the resilience slide really quick?
I can try. Let's see. There you go.
So would the definition or just the general thinking of resiliency within the system, would that also include potential redundancies that are engineered into the system as well?
Yeah, that's a great point. So here's, when you look at this definition, it's anticipate, right? So one of the things you would have is you would have, like I mentioned, you'd have two control centers, right? And then you could, if one was hacked or one was flooded or destroyed, you could have that other one. You would actually have ways that you would try to anticipate that, and then you could have extra multiple, like for instance, a data center they'll have the grid, they'll have battery backup, they'll have a couple different storage backups. So it is anticipating and having that ahead of time. But the trick is, how do you balance economics and being ready ahead of time, right? Anticipating. I mean, if you look at some of the hurricanes and that have come through, and Hurricane Katrina, for instance, there was no one anticipated the level of destruction that was there. So anticipating that was one thing. But yes, it would be where you could put in redundancies. A lot of the grid has switching capabilities where you can switch from one path to another path. For instance, if let's say a tornado comes through and knocks down part of a power grid, part of a power line, not quite as maybe extensive as a hurricane, then you can switch to that. So yes, it would include. So basically, the anticipate is figuring out ahead of time what might happen and being ready for that. One of the things, if you talk about this whole different topic, but wildfires, some of the utilities in California, actually, their way to anticipate to make sure there's not a wildfire spark from the grid is they actually cut the grid off. And that can happen also in some cases that they will cut power to certain areas during so that that doesn't create additional fires from the grid sparking and creating issues there. You then have absorb, how much extra do you have? How much power do you have that you could absorb? If you have two generators that you're using that are both at 75%, then if one generator goes off, you could use the 30% on that other generator. So you can absorb that and then just recovering from there. So yeah, good question. Other questions?
I guess I'll ask a question about microgrids. Well, you mentioned they're a little more vulnerable just due to their smaller size and easier to disturb them. But are there any security benefits to it? Just by maybe being able to, sort of partition them or separate them if something is, one is under attack or something's going wrong, and to prevent that from spreading? Or is it all negative for microgrids?
No, it's not all negative. So obviously, one of the things that happened in the 2003 blackout, the utilities that could spin off and do microgrids, we didn't really call them microgrids in there, but when they separated, if they had enough generation, they actually didn't collapse. But those that kind of hung on, because that was kind of the way to do it in 2003. So yes, you're right. You could have, from a security perspective, you could have that be separated from other resources that you might have if everything's connected and part of the communication. So yes, it could be separated. So to keep from people hacking. Obviously, if it's a microgrid, it's going to be kind of local. So you're not going to have probably as much. You'll have a local area network that you're using, but you may not be connected to some wide area network that enables folks to come in and create challenges the same way a larger grid would be there. So yeah, it can have some advantages. The trick is basically, like I said, is you got to balance. It's much as you balance, it's a bigger deal, right? If you take off a little bit versus if you're a huge power grid, you have a lot of inertia. So if there's a small change, like we cut on off lights all the time, right? We don't worry about the grid going out because of that. But if you have a microgrid, depending on the amount of generation you have, and that's really this generation you have to balance that. But yes, you could actually, from a cyber infrastructure, you could actually run it in a isolated way. And actually, this is what, if you talk about a lot of military bases in foreign countries, they run as a microgrid, right, from a security standpoint. So, and the other thing that runs as a microgrid is a shipboard power system, right? You can't run a plug from shore to the ship when it's sailing. You can when it's inland, and so those operate as isolated microgrids, and so it's harder to attack from a cybersecurity standpoint because of that isolation. And that's a big deal when we start to talk about military installations in hostile environments. It's a big deal to have it be typically that you don't want to rely on some of the local power. So you have to be able to provide the power for your operations in that microgrid.
Well, thank you.
All right. Well, thank you all. I think it's time for the break, right?
Yeah, if you're done. Thank you, Noel.
Thank you.